Hello, Calculus 12. Today we're going to see how to find the derivative of the inverse of a function. And the first thing we need to remember is what is an inverse function. And probably the key point on that is to remember that an inverse function of a function f of x is nothing but a function where the roles of x and y have been switched. That's the simplest way of remembering what an inverse function is. Now, for example, say we have a function f of x, y equals f of x, that passes through the point a comma b. Let's say this is a and this is b. So we have our main function in blue that passes through the point a comma b. The function is f of x, and we could say that the derivative or the slope of the tangent line at a could be represented by dy dx, by the ratio dy dx. In other words, rise over run. That would be our derivative slope of tangent line. Now, if that's the case, and f of x has an inverse function, the inverse function would necessarily pass, you remember we have said that x and y switch roles, so the inverse function would necessarily pass by the point b, comma, a. And here I'm hoping that you understand and you remember what an inverse function is. So if we have the inverse function here in red, and passes through the point b comma a, that's one point of this inverse function, then the slope there would have an opposite ratio. We would have a rise dx, if this was dx, now the rise is dx, and if this was the rise dy, here that would be the run would be dy. Why is that? Because x and y are switching roles. So here the slope of the tangent line would be rise over run. If we notice then, the slope of the tangent line here would be the reciprocal of the slope of the tangent line here. If this is dy over dx, this would be dx over dy. But those are the derivatives. So we can say, therefore, that the derivative of the inverse function at b, comma a is the reciprocal of the derivative of f of x at a, comma b. Mathematically speaking, we can say that the derivative of the inverse function, here we have the inverse function, we are going to use this line to express derivative. The derivative of the inverse function at b would be equal to the reciprocal of the derivative of the main function f of x at a. In general, for any point x comma f of x, we could say that the derivative of the inverse function at x would be the reciprocal of the derivative of the main function, not the inverse, the main function assessed at the inverse function at x. And remember this because we're going to be applying it all the time. We will be able to find the derivative of the inverse function just by finding the reciprocal of the derivative of the main function, but assessed at the inverse function at x. Let's see an example and see how we apply this big expression. Let's see example 1. So example 1 says if f of 3, that's the main function, equals 8, and f prime, we are still in the main function, look at that, f prime at 3, the derivative of f at 3 is 5, what do we know about the inverse function? The first thing that you need to remember, and this is from Math 12, is that if f at 3 equals 8, then talking about the inverse function, the first thing we can say is that the inverse function at 8 should equal, I hope you all have said 3. Why? X and Y, they switch roles. That's one thing we can say. Now, let's try to apply that big expression that we have just seen, the big expression. Let's try to repeat it a few times so we get familiarized with it. That derivative of the inverse function at a point x is nothing but the reciprocal of the derivative of the main function assessed at the inverse function of x. Yeah? Now let's see what our x is, and then we replace values. In this case, our x would be 8. If we analyze what's going on at 8, we can say that the derivative of our inverse function derivative at 8 should be nothing but 1 over the derivative of our main function assessed at our inverse function at 8. Bit tricky, hey? But we know that that little bit is nothing but 3. So this is the same as saying 1 over the derivative of our main function assessed at 3. And this is a given. This is a given. So we know that that is 5. Look, here is the given. We know that that is 5. So we can say that the derivative of the inverse function at 8 is 1/5. And that's as much as we can say of this function. Notice that what we did is to work from the inside towards the outside. First, we found the inverse at the value of x. Then we assessed the derivative of the main function at that value. And then we found the reciprocal. So we work from the inside towards the outside.